The National Electrical Code, NEC, mandates that a service lateral must be installed underground. Article 250.32 explicitly states that the service lateral shall be installed underground. There are several compelling reasons behind this requirement. Firstly, safety is paramount. Underground installation significantly minimizes the risk of accidental contact with live electrical wires. This is especially crucial during excavation or any other activities that take place around the building. Secondly, underground conduits offer superior protection from the elements. They shield the electrical service from weather-related damage, mechanical stress, and chemical exposure. Thirdly, aesthetics play a role. Underground installation helps maintain the visual appeal of the building and its surrounding environment, avoiding unsightly exposed wiring. A modification involving bringing the service lateral up through the electrical room and using an LB fitting through the wall would violate the NEC underground installation mandate for several reasons. 1. It creates a safety hazard. Exposed live wires within the electrical room and along the exterior wall pose a significant risk of electrical shock. 2. It compromises protection. Exposing the service lateral to the elements and potential physical damage reduces its overall reliability and lifespan. 3. It diminishes aesthetics. Exposed conduit and wiring detract from the building's overall appearance. In conclusion, any modification that deviates from the NEC requirement for underground service laterals is unacceptable. It's essential to explore alternative methods of bringing the service lateral into the building that fully comply with the NEC requirements, ensuring both safety and code compliance. These alternatives may include careful planning and execution of the underground conduit installation to minimize stress on the conduit and foundation. Consider using wider sweeps or multiple smaller bends instead of a single sharp bend to navigate around obstacles. Ensure proper backfilling and compaction around the conduit to provide adequate support and prevent settling. Explore the use of specialized conduit bending equipment to achieve precise and code-compliant bends. When dealing with large conduit sizes, such as 3-inch RGS, consider the following best practices. Firstly, proper planning is crucial. Before starting any excavation or conduit installation, carefully assess the site conditions, including soil type, existing utilities, and potential obstacles. Develop a detailed plan that outlines the conduit route, bend locations, and installation methods. Secondly, use appropriate equipment. Invest in high-quality conduit bending equipment that is specifically designed for the size and type of conduit being used. Hydraulic benders are often preferred for larger conduit sizes as they provide greater control and accuracy. Thirdly, follow manufacturer's instructions. Always adhere to the manufacturer's instructions for the conduit bending equipment and materials. This will ensure that the bends are made correctly and that the conduit is not damaged during the process. Fourthly, consider using sweeps. Sweeps are large radius bends that are used to gradually change the direction of the conduit. They are often preferred over sharp bends as they reduce stress on the conduit and make it easier to pull wires through. Fifthly, provide adequate support. Ensure that the conduit is properly supported throughout its entire length. This will prevent it from sagging or shifting, which can damage the conduit and compromise the integrity of the electrical system. Sixthly, use proper backfilling techniques. When backfilling around the conduit, use clean, granular material that is free of rocks and debris. Compact the backfill material in layers to ensure that it is properly consolidated. Seventhly, inspect the installation. After the conduit has been installed, carefully inspect it for any signs of damage or defects. Make sure that all bends are smooth and uniform, and that the conduit is properly supported. Eighthly, consider alternatives. If it is not possible to install the conduit underground without compromising the integrity of the foundation, consider alternative methods of bringing the service lateral into the building. These may include rerouting the conduit or using a different type of conduit. Ninthly, consult with a qualified electrician. If you are not familiar with the NEC requirements for underground service laterals, consult with a qualified electrician. They can help you develop a plan that meets all applicable codes and standards. The NEC provides specific guidelines for the installation of underground service laterals, covering aspects such as burial depth, conduit type, and clearances from other utilities. Adhering to these guidelines is crucial to ensure the safety and reliability of the electrical system. The required burial depth for underground service laterals varies depending on the voltage level and the type of raceway used. Generally, the minimum burial depth for rigid metal conduit (RMC) and intermediate metal conduit (INC) is 18 inches, while the minimum burial depth for rigid non-metallic conduit such as PVC is also 18 inches for direct burial. However, these depths may be reduced in certain situations, such as when the conduit is encased in concrete. The NEC also specifies the types of raceways that are permitted for underground service laterals. RMC, INC, PVC, and reinforced thermosetting resin conduit (RTRC) are all commonly used for this purpose. The choice of raceway depends on factors such as the soil conditions, the voltage level, and the required level of mechanical protection. Clearances from other utilities are also important to consider when installing underground service laterals. The NEC requires that service laterals be installed at least 12 inches away from other underground utilities, such as water pipes, gas lines, and communication cables. This helps to prevent damage to the service lateral and ensures the safety of workers who may be excavating in the area. In addition to these specific requirements, the NEC also includes general guidelines for the installation of underground wiring. These guidelines cover aspects such as the proper sealing of conduit ends, the use of grounding electrodes, and the protection of wiring from physical damage. It is important to carefully review all applicable NEC requirements before beginning any underground service lateral installation. Ignoring these requirements can lead to serious safety hazards and costly repairs. When installing underground service laterals, it is also important to consider the potential for corrosion. Underground environments can be very corrosive, and metal conduits and conductors can be susceptible to damage if they are not properly protected. To prevent corrosion, it is important to use corrosion-resistant materials and to follow proper installation practices. For example, RMC and INC should be coated with a protective coating, such as zinc or epoxy, to prevent rust. Copper conductors should be insulated with a material that is resistant to moisture and chemicals. It is also important to ensure that the conduit is properly sealed to prevent water from entering. Water can accelerate corrosion and can also create a path for electrical current to leak to ground. In addition to corrosion, underground service laterals can also be damaged by rodents and other animals. Rodents can gnaw on the insulation of conductors, creating a fire hazard. To prevent rodent damage, it is important to use rodent-resistant materials and to follow proper installation practices. For example, PVC conduit should be buried deep enough to prevent rodents from accessing it. Conductors should be insulated with a material that is resistant to rodent damage. It is also important to seal any openings in a conduit to prevent rodents from entering. Regular inspections of underground service laterals can help to identify potential problems before they become serious. During inspections, look for signs of corrosion, rodent damage, or other damage. Also, check the condition of the grounding electrodes and the seals on the conduit ends. If any problems are found, take corrective action immediately. This may involve repairing or replacing damaged components or resealing the conduit ends. By following these guidelines, you can ensure that your underground service laterals are installed safely and reliably. This will help to protect your property and prevent electrical hazards. Alternative methods of bringing the service lateral into the building without compromising NEC compliance could involve firstly rerouting the service lateral. If possible, explore alternative routes for the service lateral that avoid the need for sharp bends or large foundation penetrations. This may involve bringing the service lateral in at a different location or using a longer route. Secondly, using a different type of conduit. Consider using a flexible conduit, such as liquid-tight flexible metal conduit (LFMC) for the final connection to the building. LFMC can be bent more easily than rigid conduit, which can reduce the need for sharp bends. Thirdly, installing a pull box. Install a pull box outside the building near the foundation. This will allow you to pull the conductor through the conduit without having to make sharp bends inside the building. Fourthly, using a horizontal boring machine. A horizontal boring machine can be used to create a tunnel under the foundation without disturbing the soil or the building structure. This can be a good option if it is not possible to excavate a trench. Fifthly, consulting with a structural engineer. If you are concerned about the structural integrity of the foundation, consult with a structural engineer. They can help you determine the best way to bring the service lateral into the building without compromising the foundation's stability. Remember, safety is always the top priority when working with electricity. Always follow all applicable codes and standards, and consult with a qualified electrician if you have any questions. The integrity of the electrical service is vital for the safety and functionality of the building. Therefore, strict adherence to the NEC guidelines is paramount. By implementing these best practices, you can ensure a safe, reliable, and code-compliant electrical service installation. The NEC undergoes regular updates to reflect advancements in technology, safety practices, and industry standards. Staying informed about the latest revisions is crucial for electrical professionals to ensure compliance and maintain the highest level of safety. These revisions often address emerging issues, clarify existing requirements, and introduce new technologies that impact electrical installations. Therefore, continuous learning and professional development are essential for electrical contractors and engineers to remain current with NEC and its implications for their work. Furthermore, local amendments to the NEC may exist reflecting specific regional requirements and conditions. It is important to consult with local authorities and code officials to understand any local variations that may apply to a particular project. These local amendments could address issues such as extreme weather conditions, unique geological factors, or specific community needs. Compliance with both the NEC and any applicable local amendments is crucial for ensuring the safety and reliability of electrical installations. In addition to the technical aspects of NEC compliance, it is also important to consider the administrative and procedural requirements. This may include obtaining permits, submitting plans for review, and scheduling inspections. These processes vary depending on the jurisdiction and the scope of the project. Understanding and adhering to these administrative requirements is essential for ensuring that the project is completed legally and safely. Moreover, proper documentation is crucial for demonstrating compliance with the NEC and other applicable regulations. This may include maintaining records of permits, inspections, test results, and as-built drawings. These documents can be valuable in the event of future inspections, audits, or liability claims. Therefore, it is important to establish and maintain a comprehensive record-keeping system for all electrical projects. The NEC is not just a set of rules, but a comprehensive framework for ensuring the safety and reliability of electrical installations. By understanding the principles behind the code and following its requirements diligently, electrical professionals can protect people and property from the hazards of electricity. This requires a commitment to continuous learning, professional development, and adherence to the highest ethical standards. The NEC is a living document that evolves to meet the changing needs of the electrical industry. By staying informed and engaged, electrical professionals can play a vital role in shaping the future of the code and ensuring the safety of electrical installations for generations to come. Moreover, the NEC provides guidance on the selection and use of electrical equipment. It specifies the types of equipment that are permitted for use in different locations and under different conditions. It also includes requirements for the installation, maintenance, and testing of electrical equipment. Compliance with these requirements is essential for ensuring that the electrical equipment operates safely and reliably. The NEC also addresses the issue of electrical safety in the workplace. It includes requirements for the training of electrical workers, the use of personal protective equipment, and the implementation of safe work practices. Compliance with these requirements is essential for protecting electrical workers from the hazards of electricity. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These may include standards issued by organizations such as the Institute of Electrical and Electronics Engineers, IEE, and the National Fire Protection Association, NFPA. It is important to be aware of all applicable standards and regulations and to comply with them diligently. The NEC is a complex and comprehensive document. It is important to have a thorough understanding of the code and to apply it correctly. If you have any questions or concerns about the NEC, consult with a qualified electrician or electrical engineer. They can provide guidance and assistance to ensure that your electrical installations are safe and compliant. In summary, adhering to the NEC is crucial for ensuring the safety and reliability of electrical installations. It requires a commitment to continuous learning, professional development, and adherence to the highest ethical standards. By following the code diligently, electrical professionals can protect people and property from the hazards of electricity. Furthermore, the NEC addresses specific requirements for different types of occupancies such as residential, commercial, and industrial buildings. These requirements take into account the unique electrical needs and hazards associated with each type of occupancy. For example, the NEC includes specific requirements for the installation of ground fault circuit interrupters (GFCIs) in residential bathrooms and kitchens, where there is a higher risk of electric shock. In commercial buildings, the NEC addresses issues such as emergency lighting, fire alarm systems, and the installation of electrical equipment in hazardous locations. In industrial buildings, the NEC includes requirements for the installation of electrical equipment in areas where flammable or explosive materials are present. Compliance with these occupancy-specific requirements is essential for ensuring the safety of occupants and protecting property from electrical hazards. The NEC also addresses the issue of energy efficiency. It includes requirements for the installation of energy-efficient lighting, appliances, and other electrical equipment. Compliance with these requirements can help to reduce energy consumption and lower utility bills. In addition to the technical requirements, the NEC also includes administrative provisions. These provisions address issues such as permitting, inspections, and enforcement. Compliance with these administrative provisions is essential for ensuring that electrical installations are done legally and safely. The NEC is a dynamic document that is constantly evolving to meet the changing needs of the electrical industry. It is important to stay up to date on the latest revisions to the code and to apply them correctly. The NEC is a valuable resource for electrical professionals. It provides guidance on the safe and reliable installation of electrical systems. By following the code diligently, electrical professionals can protect people and property from the hazards of electricity.